No sound. Hey, I'm MC Toon, and I caught you off guard by making it look like I was talking when my mouth was just moving. I fooled you. Anyway, I am going to be having a discussion with Mike Check 1 2 from TikTok. This is the first flat earther. He's not. He said he's only 10% flat Earth from TikTok. First one from TikTok. There's a. I tell you, people. This guy, not Mike, but others. Um, the TikTok flirts are the cream of the crop. I mean, next year, top left, all the TikTokers are working hard on top left. I mean, they are really doing a fantastic job. And so all the YouTubers are going to have to up their game to catch up with the head start for next year that the TikTokers have on top left. Amazing stuff. Um, so the thing is, um, there's a lot of them, and and it's super. The TikTok lowers the bar for putting stuff out there. So the people that couldn't figure out how to record a video on YouTube can figure out how to do a video on TikTok. You see the problem there. The the it's the TikTokers are top left because that bar is lowered. The bar is lowered so the top lefters can get in there more. And it is mantra from 7 years ago. It's Horizon eye level. Like, no, you didn't even look it up. It's the same stuff, but like you don't see that from the YouTube ones. That they're all pointing to a map. It's a different world. They all point to a map. The AE map. Like the YouTube ones, they're like, oh well, we don't need a map. Of course you need a map. That's stupid. But um but you do get some that are like, I don't have a claim. I just know the earth, blah blah. Um, just denialist, right? Of course they have a claim. Of course they're flurfs. And when a flurf refuses to admit that they're a flurf or refuses to claim a model, there's a reason why. It's because they know it fails every test, right? You say, give me a map. They're like, oh, well, here's the AE map. Oh, well, it doesn't work for Southern Hemisphere flights. Oh, oops. So then they're stuck. They have to say, make up excuses and ad hoc reasons why it works. They'll lie and they'll say these flights don't exist. They'll lie and they'll say that that jet streams do it. Somehow, the same flight over the same area, jet streams in both directions somehow change directions. Doesn't make sense. Um, or deflect and go to a different topic. But yeah, once they get beat down on the map topic a few times, they start getting like, oh, I can't have a map, huh? So, but it doesn't do them any good in reality. The reality is there are long distance international flights. They happen. They happen all the time. Somehow people are getting to between those locations and they're taking a certain amount of time. They're putting a certain amount of fuel in their planes. That's why these absolute negative IQ people start going for the jet fuel nonsense. So jet streams are controlled by the shadow Illuminati, Masons, Jesuit, Nazis. It would, I suppose, it would have to. Um, so the I don't have a model people. There's a few of them on TikTok too. Um, and a lot of them are blockers. If you challenge them, they'll just block you because they can't handle being challenged. So, Creighton or Oregon says, instead of 10% to your church, which does nothing, donate that money to your schools and prevent flurf nonsense. The problem is, I'm not convinced that spending money on schools is actually the solution. You need a willing student. And you look at flat earthers. They were the unwilling students. Putting more money into that school wouldn't have affected that particular student because they didn't want to learn. They didn't get to be a flurf because they were smart and had critical thinking skills, but just didn't have the exposure to education. At least not in first world countries. Maybe in countries where the educational system is pretty bad. But there's no reason in the United States for anybody to have missed that, because their opportunities are there. Could be wrong. There's certainly outlier schools that may have poor education and no amount of and n amount of money could have solved that problem, maybe. But I think it's probably not the case for most first world country flurfs. You just know, you talk to them, they're like, you didn't pay attention in school, did you? You just know. You look at Mitchell from Australia. The guy's in terror. He has no clue what he's talking about. Not any clue what he's talking about, but says it with such confidence. It wasn't that the education wasn't there. He just doesn't. I mean, it could be that he could be unwilling. It could be incapable. Hard to tell the difference. Well, is Mitchell incapable of understanding? I think Mitchell is incapable of understanding geometry. So, many Karen, assuming they graduated kindergarten. Yes. Is PJCnet actually here? Not gonna scroll back. Well, anyway, no, the flurf. He's not a flurf. He's a 10% flurf, 90% globe, and he says he's coming. So you gotta listen to me talk for a little bit. Dude, I totally agree. You're right. Why hasn't or can't NASA in 2022 zoom into Earth, only 200 miles to Earth, in live video, but claims light year zoom tech? Well, they can. Himawari 8, Epic Discover, the goes east and west. We can pull them up right now. Why in 2022 can't you go look it up yourself, idiot? How about that? Right? Why do I have to go get it for you? Because you have pre-selected a conclusion. Dude, I totally agree. You're right. You have pre-selected a conclusion. You won't accept any evidence. We know that. That's why we laugh at you. This is entertainment to us. Watching you do flip-flops, roll around, look up, think up every dumb excuse possible to ignore evidence. Right? So why in 2022, when somebody's offering you $10,000 to use flat Earth, the geometry of the flat plane, to get a position fix, why can't you do it? If somebody were offering me that money, I would figure it out, right? And if it was 7 weeks into it and nobody had yet figured it out, and I was absolutely certain it was possible, I would go figure it out. The problem is, on the globe, it took 4 minutes. I issued a challenge. 4 minutes later, somebody had the answer for the globe. 7 weeks later, and no flurf can get the position using flat Earth of sextant measurements. Yet sailors do it all the time. So, dude, I totally agree. You're right. Go away. You're just dumb, right? I mean, stick around. We want to laugh at you. PJCnet, in all caps, not lowercase, says, I love lamp. I love lamp too. I love lamp too. And yes, none of them will do a challenge like I do. Yeah, well, there's that. Every time I tell people, hey, here's a sextant challenge, they're like, well, Dearth has the 3 Bitcoin challenge. No, he doesn't. Dearth doesn't have a challenge. People, Dearth's challenge is fake. We all know that. He doesn't have clear, objectively measurable criteria. He just says, for one proof. How do you measure a proof, Dearth? What is the process of measuring a proof? Because science doesn't claim proofs. So you've already left the realm of science, Dearth. But fine, give me your definition, the process you will follow to evaluate the proof that you say that you want, so that I can go pre-evaluate it myself and make sure it matches your criteria before you do it. But no, Dearth won't do that either. Number 2, Dearth doesn't have the money in escrow. He may have the money. I would not be surprised if he has the money. But it's not an escrow. If somebody, gets it, he can just always choose, nah, not going to do it. Mine is in escrow. I sent it. Brainy Beaver has it. It's not in my control. At some point in the future, maybe when I'll expire all the challenges and I'll get it back. But today I can't use it. It's out. It's gone. So, and number 3, well, there's 4. I'll give you the 4th one too. Number 3 is that the challenge cannot be changed. Flat Out Hero, these flight charts here. He said, show this route on a flight chart. People did it on computers. Ruhif did it on a computer. I think Ruhif was first. And he's like, oh, I meant paper. Oh, you changed it. You changed the challenge. So it can't be changeable on the fly. You can't move the goalpost. And number 4, you need to have independent arbitration. You can't have the guy issuing the challenge as the only judge, because he'll just say, nah. Right? So I'm the first judge in my challenge. I'm the first. If they disagree, it goes to an independent judging panel of subject matter experts, the appropriate people too, right? It's not just my friends. It's not FDFE and Team Skeptic and Simon Dan and Conspiracy Cats and Mr. Sensible as the judges. None of them are eligible to be judges in my challenge. It has to be a subject matter expert. So if it's a challenge about maps, right? I do have a challenge about maps, and the judges need to be appropriately qualified. But here's the cool thing: mic check is here. Hey, mic check. Can we get a mic check?
Hey, what's going on, guys?
All right.
So let me try to get this set up right.
All right. People can't see you yet. I'll get that set up,
Okay.
but I'm going to read from Aries in the meantime. Says, I'm not offering $1 million. I'm offering 50 buckaroos for your talent, smarts, and time invested in educating and correcting. Love you, buddy. Oh, well, thank you very much. Is that Arles or Aries? Can't tell from the font, but I will find out in a second here. It's Arles. I use a different font. I can find out. All right, well, we've got mic
All right.
check.
Hey, give me 1 second, dude. I gotta get this set up. 1 second.
All right, it's all good. I need to get it set up.
Right on. Oh,
So
I'm having issues with the charger.
there it is. So you can see his empty room. Stringer who's won for $2 says I'm a cheapskate. So all right, Arl, thank you. I need to address that a little more. Arl, thank you so much. I don't do it just for the money. I mean, it certainly changes my weekly schedule that there is money involved in this. But I did this before there was money. I used to drive Lyft and Uber. I don't have to anymore. So I thank you for that. And everybody, I want you to know, and I'm not going to say the name because he's won the green card lottery, but there's a friend of mine in Rwanda And your money that you give to this channel pays his tuition and the food for his family every month. That comes straight out of the money that comes from here. So I'm giving back. And he's been on here. He's in my Discord server. If you know who I'm talking about, you know who I'm talking about. But he said don't say anything because he's working through the process of his green card, and he doesn't want any questions about whether or not he can support himself and all that from the U.S. government when they do stuff. So, like, yeah, I gotcha. So, all right. So, all right. Mic check is he was ready. He was at the beach. He's in Hawaii. I have a feeling he's not anything like Joey Rocha, but we'll find out. Glober Mom says, "Oh, you do talk to him frequently. That's cool. That's cool. I don't talk to him super often. He's studying computer science, so that's how we found each other, on a Facebook computer science group. And so he has questions about stuff. He's like, which Linux distribution do you prefer? I'm like, I don't have a preferred Linux distribution. Sorry. Oh, mic check is a bit loud. He's a 10, I'm a 7. So, all right. Thank you, Pat the chat. His camera fell. Dude, I totally agree. You're right. Says I'm not. We're on same page. Only thinking zoom in close enough to show people. Guys. But NASA X lambs light year zoom. All right, you learn about cameras there, dude. All right. Your camera fell.
Dude, I'm having so many issues right now. So my laptop I just had to get new RAM put into it. It's like an old MacBook Pro from 2010. Oh wow. And now it's just not taking a charge. So I'm kind of screwed on that level.
Yeah.
If I got my iPad.
If it's plugged in, does it work?
What's that?
Does it work if it's plugged in?
No, it's not taking a charge whatsoever.
Oh, not at all. Okay.
Yeah. So sorry, I'm being somewhat a little messed up here. I can't get this to sit right because I got my damn let's see if I switch this like this, is this good?
That's fine.
Problem solved.
Man,
here we go.
He's flurfing it up here, people.
All right, so I can't see you at all.
You can't see what's going on. Oh, yeah. Hold on.
That's why I thought this was all on standby.
There we go. There's me. Now you can see me.
So is this going off into the world now?
This is live. Yeah. There's 319 people right here watching.
Sweet. What's up, guys? Thanks for watching my wonderful smooth intro here.
All right. So I will. That looks good. I have the horse. This is the vertical view going right now, but it works.
All right. So I had a couple buddies. I'm not going to say who right now. Maybe I'll reveal their their identity later. But they said they're sending me comments here. They're making fun of me a lot. I don't think you said that. You didn't just say that science doesn't prove a thing, did you?
Science doesn't prove things, no.
Oh, so you said science doesn't prove things.
Correct, it does not.
Yeah. Oh, okay. So then these guys are confused. What did you mean? Let's start there.
So science, so proof is binary, true or false, and it's true forever. Right?
Okay.
So if something's proven, then it can never again be questioned because it's proven, right?
So you're saying science itself doesn't make conclusions?
It draws conclusions, absolutely, but it doesn't give binary, true forever, never can be questioned again answers to anything.
Welcome to Flat Earth Debate, then.
So pick whatever scientific thing you might want to look at. Is that the absolute answer that can never again be questioned? Of course not. Everything in science is open to be questioned. So okay. If it were not open to be questioned, that would mean it's proven.
Okay.
Right? If something is proven, you can't question it again. It's proven.
Well, I mean, you could always question it again, but the question would be answered. You would just always have an answer. And the more people that hear the question and hear the answer, the better, right?
Yeah. So that's the deal of science. And there's it goes into the philosophy of science that,
okay, I understand
which
that.
really isn't our conversation here. So
possibly though, because the philosophy of science, I think is sort of, used in a way to get across a political message, or to sort of empower a sort of idea, or to gain popularity for an idea. So
yeah. So I would say, if I ever hear somebody say, the science is settled,
right,
I don't like that.
that's right. I don't like that either.
Absolutely despise hearing that. And
Okay.
when somebody says that, I'm like, there's something fishy there, because whatever it is can be questioned.
Sure. All right. Well, I'll grant you that. It's a little, I think, it's like intriguing to say, maybe instigative to say science doesn't prove anything, but I see where you're going with that. And the idea to have a sort of open mind and not to be politicized and sort of claim the mantle of quote unquote the science, I think it's fair to have a consensus. I think it's fair to have supportive evidence and compounding evidence and all of those things to make a point and to show proof of something. So I guess in that regards, I agree with you.
So a lot of the time people use the word proof when they mean evidence.
Okay.
Right. And that's fine. And I get that. And so if people mean, like, especially if they mean like lots of evidence, right? So sure. You could use that in it's a little informal or imperfect or sloppy in the wording, but it's fine for that. But like the true proof, not something that we can do. So anyway, you were popping in as I was talking about somebody that I help in Rwanda who's going to school, and the money that I make here I use to pay his tuition and help feed his family, because in Rwanda right now it's tough. And a movie that had a huge impact on me was Hotel Rwanda.
Okay.
If you haven't seen it, it will tell you what Rwanda is still dealing with today.
Yeah.
Still
so
today.
In 2005, when I just got out of the Army, I went, used the GI Bill to first go to community college to, get some credits under my belt and then go to a 4-year university. But the community college was great, but we actually, we delved into the genocide going on in Rwanda at that time. That was 2005.
Yeah.
And so 17 years ago, and I know exactly what you're talking about. Things have not gotten better.
Yeah. So anyway, I want to read this. So Tim Tully for $10 says, maybe we can dedicate a percentage of super chats from 3 or 4 channels to start a scholarship fund. When the fund reaches 100,000, half the interest goes back to the fund, the other half to the scholarship. Yeah, that's a pretty common endowment. So I would love that. And so when this guy graduates, he's less than a year away from graduating. I'm going to college.
Oh, college.
He's going to a college in Rwanda, studying computer science. So when he's done, the money that I've been sending, he will get a job. I'm hoping he's going to get a job. Still have a degree. Sure. And I'm going to continue sending that. And what I'm going to do is I'm going to put him in charge. We'll do it together of a scholarship fund. And so I'll continue sending that money to a scholarship fund. So, and I'll open it up and people can see all the details and whatever. There are actually some like scholarship, and I don't know much about them, but there are some scholarship services where you can do a scholarship and they handle the details of it. So
gotcha.
And then Green Bull says for 10 Canadian, what Tim said. So again, thank you for that. We've got some people talking science here. We got Manny Karen for 15 shekels. He's in Israel. Says science cannot prove. It can either provide supporting evidence or disprove. Yeah. And often the word falsify is used instead of disprove. It's probably a little more clear, right?
Proof is in the putting. I saw that. Okay, so I got the live feed up now. I can see a little bit.
Oh, good. Okay. And then one more from Stringers one says, give a man a fish and he eats for a day. Teach a man to fish and he says, what? No boat?
Well, there you go. You always want to go further. I get that.
All right.
What does that mean? All right, anyway, I don't know. I'll let you.
We were going to talk about rotation, right?
Sure. Talk about rotation.
I
can't feel it. It's relative.
Yeah,
it's all relative.
Yeah,
and test for it.
So there is a limit of humans can feel when we're rotating, right?
Right.
But we can't tell.
Well, wait a second. We can feel when we're rotating? No. We cannot feel when we're rotating.
But we can feel. We can feel if you're rotating, and there's an angular change per time unit that has been identified as kind of the floor of human sensing threshold. I don't know what it is offhand, but it's something that pilots study when they're getting their multi-engine certification.
So when you say we can sense the rotation, you mean through equipment we can sense the rotation?
No,
you don't mean
the human body can sense rotation, but not indefinitely perfectly. So like I was saying, the multi-engine, I know this because Wolfie 6020 was on here a while ago. So the multi-engine certification process includes studying the limit of humans' ability to sense rotation. And there's a certain amount, and the rotation of the Earth is a good deal less than that amount. So we can feel it, but the amount of rotation in the Earth is below that threshold. That's why we cannot feel it.
You're saying a test was created to sort of mimic what the Earth's rotation would feel like, and people feel that?
It had nothing to do with the rotation of the Earth. It was just a study of some sort where people, there's probably multiple studies.
So you would feel rotation in a degree that is equal to, I mean, this has to do with Earth's rotation in a sense, right?
The study didn't. So in an airplane, it's important to know, because there's the death spiral.
Okay, I understand what that means.
When you feel, you feel it, and if you can't see because you're in cloud or something, you feel because you're turning that you're not. You just feel the motion down, and even though you're rotating in a pretty tight circle compared to the Earth, you can't feel that rotation. It's below the threshold too.
Once you get locked into it.
Exactly. And so if you don't have an external visual reference and you're just going off of your feeling, then you're in trouble.
Okay. So that's evidence for you can definitely be in a situation where you're rotating and not feel it. That's what you're saying.
Yeah.
Okay. Well, that's fine. You know, we can say that, but that in and of itself does not necessarily say, all that does is say, just because you don't feel the Earth rotating doesn't mean it's not.
Yeah.
Okay. I'm with you there.
Yeah.
We can agree on that. Just because you can recreate a sort of phenomenon or create an experience for a person where they're spinning and don't feel it doesn't necessarily mean that the Earth is spinning and we don't feel it.
Yeah.
So okay.
So many Karen, and I'm gonna don't go too far down this line here, because it is I want to bring it up. Many Karen says, sit on a merry-go-round. Do you feel rotation? And yeah, we do. So we can demonstrate the feeling of rotation, right? Sit down on there, close your eyes, and you feel it. You're like, oh, I'm spinning. Now, the merry-go-round was actually my next topic, and I saw you responding to somebody, a Glober, that was wrong. So here's what people say often. Get on a merry-go-round and turn it 15 degrees per hour. Will you feel it? That is the video wrong. That I made. That's the wrong analogy, because there's multiple things at play that we might feel. We might wonder if we can feel the rotation, which in either case is below our threshold of feeling. But the more important thing is, would you feel the centrifugal force? And Rotating a merry-go-round at 15 degrees per hour does not simulate the correct amount of centrifugal force. You have to rotate it much faster to get the same centrifugal force.
The caveat to that is if you make a ridiculously large merry-go-round,
the size of the Earth.
That is the size of the Earth. That's right. And then you stand on the edge of it, and that 15 degrees an hour is 1,000 miles an hour at the edge, and you do feel it. Now that argument, I'm going to concede, that argument involves the idea of centrifugal force, which is the formula has the gravity in it, right? So gravity is what causes, right, the force.
No, the centrifugal force doesn't have gravity in it. Buoyancy does, but centrifugal force does not.
So we don't need gravity in order to calculate centrifugal force, is what you're saying?
We do not. Yeah.
Okay. Well, that seems to be a little bit of an intriguing point for a flat Earth argument to a degree. Now, I know that I don't want to go too far down this because Globy McGlobeface, you called Globy McGlobehead, which was funny.
Hold on, people don't know. I did a video promoting this on TikTok, and I called Globy McGlobeface the wrong name. I called him Globy McGlobehead, and of course, after I recorded, I'm like, oh, I got that wrong. I don't care. I'm doing it anyway. And
well, he recently shaved his head, and that became a big topic. And he changed his name. And he has a secondary account of Mooney McMoonface, so I get it.
So he commented on the TikTok video about getting the name wrong. I'm like, oh no, that's your name, Mandela effect. It's all the Mandela effect. Is he?
Well, yeah. So.
Oh, there he is.
But anyways, the point is, he did a really good video, I think, where he lays out the model, he lays out the math, and he basically said, so my intuitive point that you would feel it was correct, but he said, look, you're going to hate this, which a lot of flat earthers do hate this, and I'm not a so-called flat earther. I'm kind of in the middle, but I hate this answer as well, which is basically it's just too large. The size of the Earth, right, along with that speed of 15 degrees per hour is what sort of negates the whole effect. And even if there is an increase, if I were to travel in a straight line, 15 degrees an hour in a straight line, along with Earth's rotation going from North Pole to the equator, which would sort of mimic the movement from middle of the merry-go-round to the outside, there would be an increase of force, but yet again, it's still negligible. And so what really is tough is for folks to accept this answer as just, okay, it fits a model. It fits a model, and yet it describes something that we still don't feel. And the answer is it's just too big to feel it. I can understand why people have a hard time accepting that.
Yeah. But can we measure it?
Well, how do we measure it? Let's go to that.
With accelerometers. So we'll cover this first. The downward acceleration is about 9.8 meters per second squared.
That's what they say.
It's easy to verify. It's not. Okay. It's not really the type of thing that anybody ever challenges.
It's not controversial.
Yeah, and I've not seen a flat
earther. Even proponents of electromagnetic magnetism as the cause for this still use that as a calculation. Sure.
Yeah, and so I'm not at this point. I'm just saying that's a fact about how the acceleration is. I'm not ascribing a cause to it. Right?
Thank you. Okay.
So then people can measure that though with accelerometers. You could do it yourself by dropping something and timing it. And the more precisely you can time it, the more digits you can get in your answer.
Okay.
So the high-end accelerometers that do it are called gravimeters. The name implies something, but it's just an accelerometer. There's several different kinds, but the simplest to describe is it's an evacuated chamber, and it's kept at a certain temperature. So no matter where it is, the temperature is the same. The amount of air inside of it is the same. Almost none.
So the whole thing about this, okay, so we're describing a phenomenon. We're describing a phenomenon that is observed, and we give an exact description of how it will behave. right? And that's kind of half of the way in which we would perform science, right? You can describe its behavior, right? And you can predict it, right? But understanding what it is and where it comes from and how to recreate it is a crucial part.
It's not an absolute necessity. There's understanding how it happens, and there's understanding why it happens. They're separate things.
But this is why we have to leave the door open for what could be the cause of this phenomenon and find other ways to sort of recreate it, duplicate it, and make it happen.
All right. So now, let me get back to this though. I want to go through this. So that it's how can we test it? So you have this,
right.
and there's an object that's in that evacuated chamber, and it's lifted up and it's dropped, and they use lasers and super precise clocks to time them how long it takes to break one laser and break the other laser. Then you know how long it took to fall, and you can use simple equations to get the acceleration. So then they take these and they go all over the world. There's the IGSN 71 standard, which was from 1971, where there's thousands of these measurements all over the world, and they go back to these same places years later with a different instrument, and they get the same answer. So there's your repeatability out to about 9 digits. Some of the newer ones, better ones, are out to as much as 12 digits of precision. So they'll measure not just 9.8, not 9.81, but they'll measure 9.79537 blah 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 out to 9 digits.
And they're claiming the only difference in what they're measuring is on elevation.
They're claiming we're measuring at this location a certain acceleration.
A certain acceleration. Now what is that acceleration? Now do they I'm saying like when they're finding a certain acceleration at the same place whenever they go back, are they, I mean, is the acceleration the same every place?
No, it varies. All over the earth, it's different.
Now, when they measure out the way it varies, does that mirror the way it would vary? The acceleration would vary along that merry-go-round, essentially.
You mean does it vary in relation to the predicted centrifugal force?
Exactly.
In fact, it does. So
okay.
So
just to be fair to everyone, is you have to cite this study. You have to be able to cite this study because that is really intriguing.
Absolutely, yeah.
What that would do, in a sense, what we need to do in that situation is control for elevation, right? And you also have to control for pressure. I think that's something else that people don't really think of in these circumstances.
It's in an evacuated chamber. The pressure is the same every time.
Thank you. But so there is a sort of there's a Discovery Channel show where they talk about one of these chambers where they measure every day, every 30 minutes every day, and it's in a castle in England. I did a video on this on my TikTok page maybe 6 months ago. It's in a castle in England, and this old castle that's been converted into a laboratory, and it actually sits inside of a pond, right? It's covered by not a moat, but a pond. It's kind of funny the way it's situated, but in essence, down below, where in the room, which does not have any windows or anything, is sort of doubly encapsulated inside the building. They have one of these gravitrons or
gravimeter.
Gravimeters, right? And it's about 3 meters tall. It's about a foot wide, and it every day they're measuring as this thing drops, and they have the lasers inside of it. It's in a pressure chamber, and they're getting deviations, just small deviations every day. But what they notice is on the days where it rains and the days where the barometric pressure increases, there's an increase in the gravitational field around there, and they measure an increase in gravity, even though that thing is inside the gravimeter.
Is it pressure or is it something else?
Well, that's a really great question.
You don't know. And looking at the numbers, you don't know.
That's right.
And so the question I have is how deep in that precision is that variation being measured? Is it in digit 9 or digit 3? It's a big difference.
Well, that's it. I mean, and I don't even know what the the consequences of the differences would be. I don't know how consequential it would be to have one difference over the other. Intuitively, I just thought it was interesting how the pressure, air pressure, in such a facility that is already surrounded by water would affect it.
So my guess is because the gravimeter has a pressure sensor in it as part of its instrument,
so you think it's relating to the outside pressure?
It's keeping the pressure inside consistent. So the pressure outside, pressure changes
if
would not change the pressure inside. There can be something else,
right?
That could introduce an error or a variation.
Well, the Discovery folks concluded that it actually was there was an increase in gravitational pull because of the increase of pressure, which I just thought was intriguing. If you're unsure and you're listening to the argument about electromagnetism as an effect, and you do see the way that those sort of powers can manipulate water. You can bend water that's flowing out of a faucet with electromagnetic energy and everything like that. It does seem to be something worth exploring. So,
all right. So let me do that. All right. Globy McGlobeface, this is just an aside here, says he ran the numbers, so somebody can verify this. A 9.4 meter wide merry-go-round, so around 30 feet. As a big merry-go-round, would have to turn one revolution per 38 seconds to equate to the Earth's acceleration at the equator. So that would be like a carousel at a amusement park, right? Maybe.
So I agree with that. Yeah. I agree with the way that the model fits, and Globy's right. I'm not at all disagreeing with that. The model is correct, and the model says on this globe Earth, no matter what you think about how fast we're spinning.
All right, hold on.
You're not going to feel it.
We already went over that. PhD Tony, who works with gravimeters, says it is the gravity of the air, and that, wow. Higher pressure.
Another twist.
Higher pressure means there's more air molecules in the vicinity. That's more mass. That will change the gravitational field of that. Oh my gosh.
Stick with me.
Brilliant.
Mr. Gravimeters.
Oh, PhD Tony.
Hold on, wait a second.
Knocks it out of the park.
No. Wait a second. No, it doesn't. It doesn't knock it out of the park, because we're talking about a chamber, a vacuum chamber
outside the
where
chamber.
That extra air that is around, that is being pressurized, is not the air that's inside of the gravimeter. That's the air that's surrounding the gravimeter.
Exactly. It changes the gravitational field.
But, oh man, that's an electromagnetic field.
Good. It's so good. Oh, I love
Isn't that pressure? Couldn't you also argue that it's pressure created by an electromagnetic field? Because there's more water in the vicinity?
I got to tell you, I studied electrical engineering at university. So my guess is that was not your field of study?
You're not asking me.
Yeah.
Okay, well, no, just explain yourself. I don't want to get into that. Just explain.
All right, so electromagnetism. Lot of people say that electromagnetism is involved in the downward acceleration. But there's a ton of problems with that. And then they use different variations of electromagnetism. They use magnetism, they use electromagnetism, they use static. Static. They just throw this out, and never do they actually.
Well, we have to talk about isolate. I'm not worried about that necessarily.
They get the hypothesis. Just a second. They get the hypothesis, and then they never go and actually test their claim. So if it is electromagnetism, then you could test it by putting something inside a Faraday cage that blocks electromagnetism, and if things floated, then that would say that it's electromagnetism. But things don't float.
So you're right. I would have to know a lot more about it in order to understand how an experiment could even isolate for these sort of things, right?
Yeah.
And you're right that I'm not trained as an electrical engineer, right? And so I think it would be unfair of you to sort of attack me or anybody else for a position in which they say, hey, maybe there's something there. Now, I think the onus really is on folks who are absolutely sure that that's not the case, to be able to be so sure themselves that they can actually just explain it, right? And also understand why somebody would be confused about it, and lay it out there. And also be okay with not necessarily knowing yourself, and realizing that doesn't mean that the answer is not there, but maybe there's more for you to learn as well,
Yep.
But I think this notion that everybody just knows it's a globe, right? And there's definitely physicists, engineers, I've talked to, I'm not trying to insult anybody, astrophysicists, everybody out there, but I simply ask them, if you're the expert, then just please try to explain it. Because I don't think NASA does itself any favors with the way they conduct their interviews, and the things that they say, and the glitches and the things that happen, whatever, if you want to say people are lying about
okay,
them.
all right, let's
okay.
Too many things. You need to give me a chance. So
basically,
you said need to explain it.
Break it down. Just break it down if it's so easy to prove.
And I did. Well,
did. What you did?
The air is more dense outside of the chamber, because it can't be more dense inside of the chamber because it's kept at a constant pressure. The air outside the chamber is more dense, meaning there's more matter, meaning there's more mass, meaning it changes the gravitational field. And if your instrument is sensitive enough to identify the change in mass in the vicinity, then it will pick it up. It must pick it up. It's a confirmation that this instrument is doing what it's supposed to be doing.
So maybe I see that that's really tough, because
you said we need to be able to explain it, and I did.
Well, no, you explained it in a way that you understand it and you accept it. And what I'm going to throw in my thoughts here, and you got to address them. But you sort of said that this idea that there's more matter around the chamber, which is sealed, right? The chamber is vacuum sealed, so there's not actually more matter in it. But the fact that there's more matter, more air molecules around it, is creating a stronger gravitational field. So that definitely makes me think that, wait a second, does that mean that my gravitational mass and the gravitational mass of my house and the gravitational mass of this chair are combining to create one gravitational field right now?
Absolutely. That's how it works. Yeah, everything's a vector, and you sum the vectors.
Then how does outer space work?
What about it?
So like that, I think that would totally, like, that idea like really complicates the already hard to describe and talk about three body problem. The way bodies can orbit based on these perfect sort of orbits that are calculable and predictable.
Well, they're not perfect. They're elliptical.
Right. What I mean by perfect is I can tell you tomorrow where we're going to be. I can tell you a year from now where we're going to be in relation to everything else. Yet somehow, some way, we're also supposed to be sharing the same gravitational field.
You sum the vectors. Yeah.
That's fantastic.
It's not right.
It does seem contradictory. How can we have free-flowing, sort of free-moving bodies in a nothingness? Also, me being a free-moving sovereign body in this entity, which has overwhelming mass over me, yet I'm sharing its gravitational field. It does seem interesting. Now, I would argue that the study that you're going to post and link to us, which shows that every day or the same day every year, the calculations were the same, is actually going to list the pool, like whatever the drift was. Because, and I'm going to say this, flat earthers don't like to hear this, Bob Nodell seems to have proof that it does have something to do with elevation, but he just won't provide the data. So if you have data, and if you have the study that has that data, I will say that is, that's in your cap. So
the instrument he had was an IRU and an IRS from an airplane. It has 3 optical gyroscopes in it. And the apparently the change in elevation caused a change in pressure, which modified the instrument, and there's a lag in correcting it. So, but he didn't publish any of his data, so we can't confirm that.
he keeps making, like, this is annoying to me because I don't think it does them any good either.
Oh, no.
Their side, because he keeps making videos where he doubles down on the claim. And he talks about him in his live feeds and stuff. And it's really annoying. I've talked to people who know him personally, and they've emailed him on my behalf, and he's just not getting back to us. It's tough. So, but in that situation, so we can move on to another point.
Is Bob, like, is he one of the main people that you got your information from? Who is the breakthrough flat earther that made you really think about stuff?
No, it's just me personally. Like, I started noticing all the stupid, people making fun of it online, and people. So okay, that's a good question, and I'll get into it. I'm not going to answer that one quickly. So I think this is important. My experience, my personal life experience, right, sort of showed me that we should really question the powers that be. And we should really think twice about political elites, reasons to go to war, what's going on with the stuff we put in our bodies. Take a little personal responsibility, right? Let's figure that out. And my sort of rabbit ears started going up when I noticed that the way that people were talking about, folks in like the mainstream media, like if you didn't go along with the narrative, you were increasingly being called a flat earther or being associated with the ridiculousness of flat earth. And so me being the smart ass kid in the classroom, if you tell me not to look at something, if you tell me something is stupid, if you tell me that's ridiculous, and you've already disappointed me once or twice, I'm going to go there. And so that was my initial reasoning. And of course, then you discover guys like Dubé and other guys, right? But for me, I've never been the kind of guy to say, preach to me, I'm going to follow you. It's just, that's really compelling. Let me go look at it a little further. That's the way I've been. But I do think that there is an association that people need to understand with sort of looking at the powers that be and being a little disillusioned.
Yeah. So none of that really affects the shape of the earth, because the shape of the earth was known before the country we live in existed.
Maybe. I mean, the idea of the shape of the earth.
Not maybe. Absolutely no question. We have documents going back centuries, many centuries, from people writing about the shape of the earth. So
history has been argued since the day that first document was written.
But none of that changes that people need.
And how many documents from the 1500s that you're relying on survived?
I'm not relying on just the 1500s.
No, I know you're not just. Do you understand my point?
The number of documents is magnificently large.
For a fact that the way that everything has gone down, that the way that the reason why the Vatican was the first one to discover basically the ideas that undermined creationism. The idea that politics in the Vatican.
Hold on. I can't let that go.
Yeah.
It wasn't the Vatican. It was a scientist that happened to have gone to a school to be a priest, but wasn't at the time going to school to be a priest, and wasn't ever a priest.
He's loosely associated with it to a point that you can make the association. And his studies, when he died, what's the scientist's name?
George Lemaitre.
So when he died, who took over his notes?
I don't know. It doesn't matter. It wasn't.
It does matter.
The Vatican.
Because his notes were not published until after he died. That's important to know.
His notes?
So there's reasons why
did he share that information with people before he died?
Look,
he did.
There's reasons.
There are people that knew about it before he died and were testing his ideas before he died. Right?
But the idea, look, I can totally tell you that it's valid. It's a valid thing to consider. It's a valid thing to look at. It's part of our history. But to conclude that absolutely, for sure that there's been no foul play, that that this is the way it should have gone down, especially living through the last couple of years. Could you imagine if the powers that be got to write the history of the way everything has gone down? Or maybe the political power that you disagree with got to write the history. What if Donald Trump got to write the history?
But none of this changes the shape of the earth. None of it does. You can test it yourself.
Okay, so why does it matter? Why does the shape of the earth matter?
Yourself. Because people that get the shape
No,
of the
you
Earth
say
wrong,
you can test it yourself, but we've gone over
I was answering.
Okay.
Because in order to say that the shape of the Earth is different than what it actually is, requires a huge amount of lack of critical thinking skills. And for people to get to that point, it damages their critical thinking skills. That's why it matters to me.
Okay, so I do feel that if you consider the idea that we're created, that there's got to be some sort of creator, whether it's the creator that's responsible for the Big Bang or whatever, that there is some sort of creation going on. There is some sort of design happening, right? And I think that that's not a fairly controversial point of view for people to have, even if they're not Christian or Islamic or anything.
Come on.
But the
point.
Well, the point is that if you're going to go ahead and sort of dictate to people, right, about the shape of the Earth, about the way that it is,
it's not dictated. Go measure it. You can do it yourself.
No, I can't. I cannot measure it myself.
You absolutely can. You can. So I did it myself multiple times.
You discovered a curvature that matches 8.5 inches per mile square.
No, that wrong formula.
That works for the first 250 miles.
It's the wrong formula. It's not the right formula.
It works for the first 250 miles.
It has nothing to do with that at all. That's not
the
rate of curvature.
Can you just admit that it works? It does work for the first 250 miles. I'm making a heliocentric point.
It has its purposes in a very specific and narrow usage, but your usage is not the right usage.
So so use the exact trigonomic formula to discover that your image that you were looking at fits the model.
It wasn't an image. Like, I did it myself. So I did science, right?
I think you're getting. I
hypothesized that the Earth was a globe, and I also simultaneously hypothesized that the Earth was flat. And then I made a prediction based on those two hypotheses. One, if the Earth is a globe, then the horizon must dip more with increasing elevation, right? And the geometry for that is not very complicated, but we can just do the true false. Yes, the horizon should dip if the Earth is a sphere.
What standard do we
hold on? Let me finish. The hypothesis.
No, you can't move forward from there, because your hypothesis has to be based on a rule or a law. And so, what rule or law says that that's the only reason? That's the only evidence that would prove a globe.
No, that I'm doing science here. The only reason that would prove a globe is not how science works. You have a hypothesis.
No, but you said I put a hypothesis. You said I put a hypothesis out that the world is round, and I put a hypothesis out that the world is flat. And then I used these measurements, and the measurements, lo and behold, match the round Earth. But you're the one who already put out the predeterminants. You said, okay, what was the determining factor that this match?
I will answer that question, but you can't interrupt me when I'm answering it, okay? Please let me finish this thought. You're nice enough, Mike. You can follow this. Okay, so hypothesis 1. And the prediction is that the horizon must dip. And I'll go over why that must be the case. Hypothesis 2, the Earth is flat, and the horizon must not dip, at least not measurably dip, with increasing elevation. Okay, the reason why the horizon must dip with increasing elevation is because it curves down. And so as you get higher, that dip is more. And there's a geometric function for that. And at the height of an airplane, about 35,000 feet, it should be between 3.2 to 3.5 degrees dip.
Okay.
For the flat Earth, the geometry again isn't terribly complicated, but in general, if you can draw a sideways view and then draw a triangle, and go from your position, do it to scale, to wherever you think the farthest point is that you're looking over flat Earth, and then how far down that is, right? So 35,000 feet, but it's going to be thousands of miles long in one direction. So that triangle is going to be super skinny one way and long the other direction. And so that actual angle is going to be very close to zero.
Right.
So those are the predictions.
Can I interject?
Yeah. All right.
So your point about if I increase my elevation on a ball, the horizon will drop. That is not at all controversial to me. I don't see any problem intuitively. It makes sense to me, right? The only thing is I think we could be fooled a little bit by atmospheric refraction, and it doesn't actually drop enough, right? It doesn't drop as much as we would think it would, right?
Yeah, and refraction will cause it to appear slightly higher.
Now, the other point I want to make is your assertion that that a flat plane, the horizon itself would never change with elevation. And I want to challenge that a bit, because I want you to imagine yourself, let's say you're on top of a skyscraper, and on top of that skyscraper is a flat tennis court. And the edge of that tennis court is the edge of the skyscraper. You're falling off of it, right? If you're standing on the tennis court, you can see that horizon line perfectly, the edge of that tennis court perfectly. But if you were to lie down, belly down, right, and even maybe put a small camera right at ground level, that horizon line would seem a lot closer. There would be an illusion to the fact of where that tennis court actually ended. And as you lifted that camera,
what would the dip change?
Well, but the point, let me finish the point. And as I lifted that camera, I would see more of the tennis court. Now let's make this tennis court huge, right? So my point is, even on a flat plane, my horizon is going to change with elevation.
But we can test this by just applying the math.
But we have to be careful that when we apply that math, that we're not applying math that has to do with perspective, right? That has to do with optics. That has to do with the design and the way that light behaves.
Right. It's not that hard to do.
And that we're actually using math that defines that it's undeniable. You cannot confuse this calculation with anything else that says this is exactly the way a ball would act and nothing else.
Yeah.
Well,
it's
if
not,
that is proven,
it's not complicated.
So if that is
math.
proven, I think, but if it's not complicated and it's not proven, I think the problem is in the communication. Then how come this message is not being communicated clearly or not being laid out in such a way that people
I'm
just understand?
Trying to communicate it to you right now.
but I'm trying to show you the way that so then address the basketball or the tennis court analogy.
Right, so
and why that work.
I can show you. I can draw it for you. Right.
Okay.
So let's see. Where's my Sharpie? Somebody took my Sharpie. It was probably me that took my Sharpie.
I mean, we are sort of debating, I guess, on how we determine if the scientific method that we're using has a basis, has a control in which we're able to sort of determine that our measurement says what it says. All
right. So here is,
and I don't want you to assume the globe before you lay it.
Well, I'm assuming flat Earth right here. All right. So here is, I'm assuming flat Earth. Hypothesis that the Earth is flat. And here is the Earth, and here is the viewer in an airplane. Right? So 35,000 feet. So let's take your example of a tennis court, and let's say that it's not significantly large in comparison to how big or how high you are. So maybe they're just a few distances away to the edge of the tennis court, right? So here's the edge of the tennis court, is this little,
I see it
right there.
Right.
Okay. So then we draw the angle down from where you're at to the tennis court, and we can get a protractor and we can measure this angle here. Right? So if you draw that to scale, you can measure that angle.
Okay.
Right. Now, let's move, I'll move all the way to the edge of the paper and draw the edge of the tennis court there at the edge of the paper. And this is maybe, I don't know, 10 to 15 times the height, right? So it's not that much of a difference. So this is actually still not a very big tennis court. So here we've got We've got that again, and we've got the angle now this time is smaller, right? But we've maybe got a 15:1 ratio.
Okay.
Right. So now if you increase it, and I don't have enough paper, my paper's now not big enough. Expand that out so that it's a 1,000:1 ratio. That theta, that angle is going to get smaller. So so we can take things like the known maximum distance that you could go in any one direction on flat Earth, right? You could
the known maximum that we would be able to see on a flat Earth?
No, that the plane of the flat Earth, if it existed, would be. So if you look at the azimuthal equidistant map, which is what most use, the most common one here.
Right.
So
there has been, I will say, like, I don't know if you've seen like the 6 or 7 South American scientists that put up cameras all over the world, and they measured the arc and the time of the sun, and they came up with a slightly different map, which I'm intrigued by because I've always put it on flat earthers.
I think you're talking about Bilu.
I'm not sure. I just recently saw it.
Were they Brazilian?
Possibly. I mean, you can address it. I just recently saw it.
Okay.
But they came up with a whole other...
The same people in a follow-up video. The ideas that they got that video from, they talked to the individual that gave them the ideas. This individual's name is Bilu. He's an alien. They talked to an alien who was hiding in a bush.
Okay.
So this documentary a few years ago was super huge. And
I don't ever take stuff like that at face value. I gotta look into it myself.
I have the Bilu.
That sounds wild.
All right. Anyway, so you take this map. It doesn't matter. You take any map. There's only a certain amount of space you can go. Some people say the Earth is indefinitely big. It just infinite plane keeps going. That doesn't help. Right? If it's indefinitely large, then that makes that angle even smaller, because that distance between the observer and the farthest point is longer, making that angle even smaller. So, so from the center to the edge is 20,000 kilometers.
Right.
On this map. Right? According to the scale, that's on the bottom of the map right there. In fact, the scale only gives for latitude. It doesn't give a longitude scale, so it's not very good. But so if you're 35,000 feet high, which is a couple kilometers high, compared to 20,000 kilometers or even 10,000 kilometers, it's a drastically big differential in the height versus the length there. And so that angle is very, very small. So that's how we can know that if the Earth were flat, that the non-refracted angle would have to be incredibly small. So small that it would be very difficult to get a measurement instrument to do it.
And aren't we also, but we're also limited by distance factors. I mean, we can't actually like perform this experiment. First of all, there's not many places on Earth where we would be able to perform such.
Anytime you're in an airplane, you could do it. Because you're higher than all the topography when you're in an airplane.
But when you're in an airplane, you're already looking through layers of atmospheric pressure. You're looking through layers of atmosphere. And so if you're going to be in an airplane and look at an object on the ground and measure your angle to that object reliably, time after time, you don't think it's going to be affected at all by pressure?
It absolutely can be affected by refraction. So that's why I said the non-refracted.
All
right. So you do this incrementally. Right?
Okay, so now
you do one step, then you add in the next probable largest factor, and then the next probable largest. And then at some point you're like, okay, my ability to measure my interest in getting more digits of precision is exhausted. I'm not going to measure any. I'm not going to include anything.
So would you argue to a skeptic then that equipment that we have today, like infrared cameras, infrared lenses that we can put on telescopes that would look through that sort of refracted layers that they can see through,
infrared is refracted too.
It's going to be refracting image. So do you think that there's an argument that we don't actually have capabilities to demonstrate that the length that we would need to see to prove a flat Earth is even able to be seen?
There's no problem seeing that far.
No problem seeing that far.
Yeah.
Okay. Well, I think then that would be pretty. So for me, I would say to a flat earther is like, there you go. There's your challenge, is to actually capture something, capture an image, or find a place where you actually can see further than the heliocentric model would allow you to. Now, if you can be so confident that not such a thing exists and it's impossible, I think there you have a solid piece of evidence that would suggest that we're probably on a globe, right?
So let me come back. Let me add something to this that is really relevant. So Samuel Rowbotham is the 1800s guy that started this most recent flat Earth movement, right? Do you know that?
Who's this?
Samuel Rowbotham. He was a guy in England.
Yes. I know about Rowbotham.
Yeah, all right. So he
Eric
wrote a
Dubé
book.
talks about him a lot. Like I'm well versed. I'm well versed on both sides. Okay. Like I try. So
I've read Rowbotham's
Dubé, and
book.
I watched MIT lectures on gravity. So okay.
So I've read Rowbotham's book. So both Rowbotham and Eric Dubé agree that if the Earth is flat, the horizon must rise to eye level. It is Dubé's point number 2.
Understood.
He says that. Then he goes and shows pictures without any measurements and declares, without any measurements, that the horizon rose to eye level. But people go and measure to see if the horizon does rise to eye level, and it never does. So Dubé and Rowbotham themselves, and many others, say that the horizon must rise to eye level if the Earth is flat. This isn't just my invented thing. This isn't just Glober's thing. This actually came from Rowbotham.
I agree with that.
Right?
But I still say that if there's a possibility that what they're saying intuitively is correct, and I don't deny it. Like I say, if it's a globe, as you rise, the horizon should dip. If it's flat, the horizon should stay level. But where's our starting point, right? Like I said, if I'm starting laying down at ground level on that tennis court, and then I come up, that horizon's not actually at my eye level. The horizon is below my eye level. I don't realize that.
But we know how much.
I think there's a point that we need to rise. I think there's a point that we need to rise until it does reach eye level. And then there's a point that we go higher and it extends further. And then we're dealing with all kinds of things that you addressed. And I know that you said it's on a day where refraction is not in play, but I just don't know how refraction could ever not be in play.
Well, no. I did not say it was on a day with no refraction.
There's an average day. There's an average day in our 365 days where the vision is set. And that's where we say there's no refraction.
There is refraction. I'm going through the process of
I'm going to let you finish this. I just heard, so I'm just going to have to take like a little intermission just for a couple minutes, but finish your point.
Okay.
And then
step 1, do the calculation for the base step, then include in other modifications to it, and refraction would be the next one. But if you need to go for a second,
just for a few minutes, if you don't mind.
Yeah, that's fine.
Okay. Tackle some comments. I'll be back.
All right. Let me. I will turn off so you don't hear him if he's. I hear him talking in the background a little bit, so I'll give him some privacy there. PhD Tony, perhaps rather than optical evidence, you could start with Rayleigh waves and atmospheric pressure waves that propagate from point of origin, converge in the antipode, and do multiple times. PhD Tony, do you think he would get that? Do you really think he can't get this? This was, he's like, you need to explain it better. I'm like, this is 8th grade. He's not going to, I'm sorry, PhD Tony. I get it. You nail it. It's really good. But, all right, let me catch up on couple super chats here. Oh dear. People. Strangers one, Many Karen, William Foley. Oh yes, I have to ask that, William Foley. Does Mike check driver travel? I'll have to get back. Technix1 says when a pencil falls down, the earth also moves up. Does is again the scale. The scale. Is he? Yeah. Joe Whip, yeah, yes. I'm with you, Joe Whip. People read what he said if you're wondering what I'm responding to. Mr. QTube, first name Fa, says for $5, are we talking about the same Vatican that almost executed Galileo for disproving the geocentric Earth? Yes, the same Vatican. Like it matters. It's a religion. It's not science. Now, for a long time, the Vatican had a lot to do with science. Not a good idea. But they did. And they put out some good stuff when they, some of the time. A lot of the people that figured out the shape of the earth were, some of them, full-time working for the churches. The Catholic Church, or a lot of Catholic Church people, I guess. Maybe that's why people don't like it. They're like, ooh, they think for some reason that everything that the Catholic Church does is wrong. I don't get that. Whether you dislike or like the Catholic Church, putting out good, solid science is the same, regardless of the source. So, Cretan Bull for five Canadian says, Aristotle knew the earth was a sphere 300 years before Jesus walked the planet. He wasn't part of some anti-Christian plot. That's very true. It's hard to be when he didn't exist yet. So, Marty Mad Scientist says, disbelief in physics is a guaranteed direct short bus to whichever mythological hell you choose to subscribe to. It's full of skeptical fools. Yeah, it's not skeptical. Is it? Skeptical is the wrong word. It's denialist. Right? There's a difference between denial and skeptic. And they call themselves skeptics without realizing they're just denialists. Now, I don't think Mike is quite there. I don't think so. He's pretty good, but he's digging his heels in right here. So we'll see if we can come around a little more. Ben Duhova says, you butchered my name in the live stream earlier. It's said Benduova. Benduova? Imagine you're Arnold Schwarzenegger saying it. Otherwise, love your work. All right. Benduova. How's that? Oh, I hear myself talking back on his side. I'm gonna have to mute my outgoing to him because it's feeding back. I can hear it. You can't. There we go. Muting myself so that he doesn't hear me talking. Lubo in China, please bring the fact that we have photos from satellites of our globe Earth. Yes. All right. Well, thank you, Benduova. Tickle Me Bilu says, Bilu loved MC Toon for remembering Bilu. I love when they bring up the Convex Earth documentary. That's what it's called. The Portuguese, they're Portuguese speaking, they're Brazilians. They do this, it's garbage science too. It's you can tell when you watch it critically, they just faked that. That was a fake. They're like, we were this far apart. And then you actually look at it. They weren't actually that far apart. He's coming back. I can hear him. I can hear myself on his side still. Oh my gosh, it's distracting me. All right, that's all good. Many Karen says for 15 shekels, tell him to listen to Dubé claiming the horizon always rises to eye level. That's the thing. That's what they say. So, yeah. Flat earthers don't all adhere to the same idea, which is not a good thing. Because when more people are in agreement about something and have tested it and have explored it and have come to that conclusion through independent means, that's more confirmation of the accuracy of that thing. 100 flat earthers with 100 different explanations to the same problem, that doesn't explain problem number 2, isn't a good thing. It's a very bad thing, especially when that problem is explained on the globe very well, along with simultaneously lots of other explanations. So, all right, Beach 8 said, this is your brain on derp, kids. Don't do derp or meth. Many Karen, we don't have a model. As soon as you say the earth is flat, you have a model. It's very crude, but it's still a model and it's still testable and easily falsifiable. If you ask for the starting point again, you should ask why eye level isn't the starting point. That's kind of the reason it's used. It's the flipping starting point, says Heat Shield. Yep. All right. Truth Nerds says for €4.99 says the Globe Flurf has a ton of questions and done no research, together with the smug grin that makes him a strong future top left contestant. Let's hope not. Let's hope for not. Oh, he's coming back. All right, you're back.
I'm back. All right, so you got to give me a second to clarify a couple of things since I've been listening to you.
Oh, okay.
All right, so folks are, making their funny comments about things. So I'm not necessarily a flat earther. In fact, I'm not a flat earther. And I'd like folks to go to my TikTok page and look at my pinned video. Mic check 1, 2. Hopefully you provided a link for them. And if not, hit you up. Okay, thank you. But go there and check out my pinned video. I sort of articulate my position. I concede, right, that the evidence is on the heliocentric side. I concede that. But what I'm saying is that I'm not 100% sure. And I try to lay out why. And I try to challenge both sides to be very good at being able to explain themselves, at being able to explain why they see it the way they see it. Now, I find that there's some very articulate and persuasive flat earthers, but Eric Dubé is not one of them to me. Okay,
that's good. But okay. he was the first, wasn't he?
Well, he's
come on. You watched that video. So we all know that was the video you watched.
No, the 200 proofs.
Yeah.
No, because the first video I actually watched was the 200, like the debunks, like when people debunked it. So that's how late in the game I was like people had already like put out the debunk videos. And like I said, so I saw the debunk videos first, but I was like, like I told you, I'm attracted to, like, if you're going to attack an idea, I'm going to listen to that idea a little bit. But I also prescribe, you guys were talking about Aristotle. I also prescribe to ancient Greek wisdom that says, and I think this was either Plato or Socrates, that basically said you can hold an idea in your head without adopting it, then you can understand it. And that's intelligent, Now, just understanding something doesn't mean you adopt it. And what I'm trying to speak to is understanding why people see the earth as flat and understanding what I see are their questions in the heliocentric model and how, for certain, folks can be so sure that they are absolutely right without actually, going to space or being an authority themselves. And the idea of once upon a time of saying, hey, listen to the scientists, listen to the guys who actually have a job that deals with this, listen to the people who do the physics, whose livelihood depends on it. I think it is undermined by our sort of zeitgeist, our political culture right now, right? And so the onus really is on you guys. It's not fair, but if you're going to get into the into the debate, MC Tune, I just really implore you to not be so frustrated with it, but really try to understand.
I'm not frustrated.
Well, to the point that you sort
of.
I
love this. It's fun.
Right, but I don't think it's so classy to sort of dig on people and to make fun of people's intelligence and to come to conclusions that people must be A, B, or C.
That's not what I do.
Well, if the word stupid or anything alike has ever come out of your mouth in describing people with a different point of view, that's probably what you're doing. You know, and I just implore you to you might have all the rationalization in the world.
Think maybe you probably don't know me too well. That's not who I am.
But it is a bit of your persona online. And I think online personas, well, you're laughing. I mean, okay. I've seen your videos. I've heard the things you said. You're not the worst of the worst. I'm not trying to hang you on I'm not trying to persecute here. And I'm certainly not here to bash you. I'm really just trying to appeal to this idea of like, and maybe the people making comments, let's not be so quick to just like slap people down as stupid and naive. But let's really take a moment to listen to where they might be coming from. And if you truly are the smarter person, I implore you to be able to understand the dumber person's point of view and then explain to them their errors without hurting their feelings or acting like you're, holier than thou. So, and that's all it is really. But getting back to our point, right? Let's get back on track.
Okay.
Right.
Question though, William Foley says, do you drive or do you travel?
Well, you need to drive in order to travel sometimes. You can walk to travel.
Okay.
You can boat to travel, or you can drive to travel. That's a good answer.
Yeah, they know now that you are not a sovereign citizen.
Well, whatever it's true. What does that mean? Explain that.
So there's a large overlap in the community of flat Earth debunkers and sovereign citizen First Amendment auditor debunkers.
Yes. Oh my goodness. Why are people always trying to find out what ounce you might be instead of just dealing with what I'm saying direct at face value?
I think there are a couple times that people heard you use some words that some of the sovereign citizens use. And I think that made them wonder, because there's not just an overlap in the debunkers doing, but there's an overlap in flat earthers and sovereign citizens. There's a handful of them that are like doing they're going and getting themselves arrested and then claiming that, oh, well, that doesn't apply to me because of this, because and it's silly,
Understood, but people will do that. People are going to associate with all kinds of things, and you're going to overlap. We all have those bubbles that we can overlap.
All right, so here's a question. I think this is a very valid question from PhD Tony. Now he works, as I mentioned earlier, he works with gravimeters. His entire job relies on the measurements from gravity. So he says that he wants you want him to treat people who call him and his colleagues liars and incompetent. You want them to treat you with respect when you are saying, or maybe more appropriately, flat earthers in general, and maybe you want to leave yourself off that list, right? But up to you. Calling them incompetent and liars, because they have to be liars in order for the earth to be flat.
All right. So PhD Tony, for you to have the job that you do and do what you do, it's pretty ridiculous for somebody to call you a liar and evil or anything out the bat. I think we can all agree on that. Calling you a liar for standing up for your job or what you believe in or what you find to be true in your daily practice is ridiculous, right? And we can understand that. I think appealing to the ridiculous folks that will exist in this realm is silly. Like, please don't give them any more attention than they really deserve. That being said, if you want to address it because it's happening a lot and it's becoming sort of popular and people are being influenced by this, like I said, take the higher ground. They're idiots if they call you that, and you have the information, you have the ability to articulate why they're wrong. And if people don't accept it, they don't accept it, but at least, you've done the better job. I think that giving people power, and giving the excuse that, oh, they did this, so now I have a reason to sort of go below who I ordinarily would be as a human being, and now just go after them. And like, I do this and then get high and mighty. I do this for a job, like, how dare you? Like that doesn't convince anybody other than the people that were already convinced, So sorry, Tony, that happens to you, but they're idiots, right? Whatever.
All right. Okay. Well, what was the? Where were we?
I'm sorry, but I just don't understand this point of sort of pitting people against each other. We're here to just talk about things as they are, and we can wax poetically about the psychology of other individuals. And he said this, and this person was so mean. But man, I've received it in so many different ways, especially starting out, and it's almost empowering to not give into it. So just don't give into it.
So I can understand, and maybe the history is useful to know why the response is what it is. When a flat earther comes in and says, "Oh, well, this is the way it is," and somebody says, "Oh, well," somebody says,
I'm reading comments right now that tried not to insult but still insulted. Are they referring to me? That doesn't make sense. I didn't insult anybody. I certainly didn't insult Tony.
Well, by saying, if anybody were to say gravity doesn't exist, or gravimeters don't work, or all of those types of things,
nobody said that.
It I'm not saying you did, but it's
okay.
It is what, in general, flat earthers reject gravity, and so it's almost his entire job.
They don't reject the phenomena. They don't reject things, the idea that things fall. They don't reject the idea that there's buoyancy.
They reject mass attracting mass, which is gravity, which is what he does, because which he relies on for his job.
If I dropped it, if I blew a bubble or dropped a tissue next to an oil tanker, you're not going to be able to measure any gravitational pull. I mean, if I drop two bowling balls 100 feet up in the air, 10 feet away from each other, are you going to measure that they actually land closer together? Like there's
you potentially could do those types of
measurements,
but you could do even better.
We do this stuff,
but you could do even better measurement, right?
Well,
you could
right?
take no. The gravimeter doesn't verify mass attracting mass in and of itself.
Okay.
The variations in the gravimeter point very strongly towards a rotating Earth with a specific mass.
Wait a second. So is this the point of mass attracting mass? Is this why the argument about having more matter around the gravitron or gravimeter would cause it, because you've got more mass attracting mass? But that means that that means it's the mass surrounding it that is pushing down on it, rather than the mass of the core, which is pulling everything in.
Now, remember,
it seems to be a different direction.
You have to sum the vectors.
You have to sum the vectors. I will admit ignorance there. Okay. I'm not even going to try to argue with you on that point, and I'm not going to.
You know what a vector is, though, right?
I do know what a vector is.
It's a quantity and a direction.
Vector, and you're talking about all these different directions. I'm not ready to. I'm not ready to go there right there. But I'm just going to have to say we'll agree to disagree.
I would say, without having seen what it is that you're talking about, but I would hypothesize that when the air pressure is higher, the bulk of the change in the air pressure is above where the gravimeter is, right? And air pressure change doesn't change the air pressure or the quantity of mass below the gravimeter. It mostly changes the quantity above. So I would hypothesize that it reduced.
But I believe all the experiments.
Hold on, I wasn't done. I was right in the middle of my sentence. The last sentence, and you.
I'm sorry.
Please.
I'm sorry. Go ahead.
That it would reduce the downward magnitude of gravity.
It would reduce the downward magnitude. Okay.
Yes.
Right. Okay. So that seems to be all right. So there's experiments where they'll put mass underneath the scale and sort of show that there's an increase.
Yep.
Underneath the scale.
Again, you can test that.
Okay.
And there's other ways to do it. You could take a bar, take a bigger one, And you could put a mass on both sides of it and then suspend it with a wire and let it come to an equilibrium. So there's the twist on the wire is all done, right?
You got some real classy people in here. So what is it? Real CY genius or real whatever. It's your entire douchebag existence that is an insult to humanity. Where is Professor Dave when we need him? I mean, that there you go.
That's what Professor Dave said to Dearth.
Oh, is that what he said? So there you go.
Yeah,
so you got
what
fans.
He said to Dearth.
This is like WWE like fandom stuff here that happens. I don't like it on both sides. It happens on the flat earth side. It happens here on the globe side. You guys need to get a life, whatever.
What am I doing though? Am I saying that to you?
No, you're not.
I'm trying to explain to you.
I do think people enjoy this a bit. And I'm not a flat earther, which is so funny. I'm just really trying to appeal to a bit of empathy and trying to understand and also trying to serve as a bit of a value to you. You know, if you do have the reign of truth, maybe hearing my perspective a bit can help you communicate your truth a little more effectively and not have to run into so many, obstacles, because there is a way that you guys talk to folks. And I don't mean to generalize, but but
you're generalizing. I get
it. But it is you guys. I know that can be reflexive. That can cause reflexive emotion. But so, and if it's not necessarily you, there are the people out there that sort of make their claim to fame by just making fun of the opposition. Just going after it. And that sort of thing, if you're new to like the flat earth, or if somehow, some way you came into it because maybe you were skeptical about other things that impacted your life, reasons to go to war or what's happening with medicine, I don't know, whatever's going on, whatever's happened in your life that opened you up to the possibility of this. And you see the same behaviors of the authorities mocking and making fun of people. Well, you guys are just adding fuel to the fire. You're giving a little bit of legitimacy to the skeptics by behaving that way.
Okay. Right? So maybe find those people, because that's not me.
Well, I don't want to spend too much time being a referee on your stuff, MC. I think you are guilty, but I'm not I don't have an example to pop off on top of my head. But if that's not you, that's great. I don't want to say that is you. And if I'm wrong, I'm happy to be wrong about that. And yeah, keep it up. Don't be that guy.
Right. So I was explaining something. Go back to that.
Sure.
Take a bar. I mean, reading the chat's not going to be good for you.
All right. I'll ignore it. I'll close it off. All right.
All right, take the bar. Put a big hunk of something on both sides that has a lot of mass. Have it be the same amount so the bar doesn't wobble. Let it rest. Then come along and put here a large mass and over here a large mass. If mass attracts mass, it should twist the bar.
Right? Are you isolating electromagnetic forces?
Absolutely. Super easy to do. All you do is you have everything with a common ground.
Right? What do you mean? How can you have suspended things with a common ground?
What's suspending it? A wire. What's that wire attached to? It's a wire. So if it's attached to anything metal, then
those spheres are going to have a field.
Yeah, but
they're going to have poles on the field. You don't just because you ground something, you don't take away the poles. No, am I wrong on that? Like
yes, you're wrong on that. You all right. There are multiple parts to electromagnetism. So when you have a common ground, the electrostatic potential is the same.
Yeah, but we're not talking about electrostatic.
Well, like I said, there's multiple, and so different people have attempted to try to debunk
and listen,
this.
I'm just asking how you isolate it.
So
explain how you isolate it.
How you isolate? Well, what one specific thing would you like me to first address?
How are you isolating gravity from every other type of magnetic force?
One. Give me the first one. I was explaining one of them. I chose at random, the wrong one apparently. Which one should I address first?
Are you okay? Just answer. Are you able to actually address all of them?
Yes.
Okay, well then we don't need to go into it.
Okay.
If that's addressable, if you say that it's addressable, I'm not asking for you to lay it out here and give us a science class right now.
Okay.
But that is something that would be part of that experiment. That if you're going to say that I know for a fact that when I hang these lead balls on a suspended wire and I've completely sealed off any air drift, anything that's going on, and I know for a fact that I've isolated for every type of electromagnetic or magnetism, factor that's out there. If that's demonstratable, if that's something I can read and something that's peer reviewed and something that's out there and something that is easily demonstratable, but then that's that. Then why does this argument still exist?
Because when I send this link, and I'll show it to you. When they're like gravity blah blah, and they're like they like to say gravity has never been proven. And of course, it's a loaded word to talk about proven, but I get what they say. Like
what you started with, right?
Yeah, is there lots of evidence for it? Yes, there's lots of evidence for it. So I'll send this. It's just mctoon.net/G, right? And you said peer reviewed. This is 18 or 19, I forget. Different peer reviewed measurements of the strength of gravity, using many of them using the same method I showed you. One of the ones that is super detailed, they go over a large amount of their actual controls in this, is this one here from 2014. The BIPM measurement of the Newtonian constant of gravitation, G. They specifically got, is that the wrong one? Yeah. They specifically demagnetized the masses on both sides. They used a particular metal that was less susceptible to magnetism. They did it in an evacuated chamber so that there's no air currents. It's all made of metal, so it's all electrically the same. They did not use spheres. They used cylinders because cylinders are easier to get the same mass and measure the mass of a cylinder versus a sphere. And then they went on pages and pages. So all right, so here's the sphere. I think the spheres are the masses on the beam or the bar, and then the masses are the ones that the introduce on the side are the ones that are cylindrical. And I'm looking for a specific thing where they talk about I missed it. The error budget that they talk about. So all the different things, the things that they did, let's see.
Uncertain.
The things that they did to control the things that you're concerned about. And here's, your concerns are not new, right? I see it all the time from people. What about this? What about this? What about this? These are free. I didn't pay any money to get this. And have you never heard, do your own research? It's out there. You can do it. I did my own research. I found these. They're all over the place. There's tons of them. So here you go. Possible magnetic interactions between the source and test masses. They actually did a whole bunch of work to make sure that wasn't a problem.
All right. Well, right on, man. I mean, that's great. So that's on your website.
Yeah. So now when I send that to somebody.
So that's worth looking at. I'm not going to.
What do they do though? What do they do when I send that to them?
Well, hopefully they read it. I don't know.
They never read it.
Well,
they never read it.
Well, they're like, there you go.
There's lots of excuses. They're like, oh, that's just peer reviewed, which is garbage. That's just scientism. That's just, and then something.
Could be, but it's stupid to just say that without double checking yourself.
It could be.
Just as dumb as like the other side.
Yeah. It could be, look at it and find out if it's the case. I sent somebody, there's another one, measurements of the rotation of the Earth. MC2.net, hold on. mctoon.net/spin is 14 measurements of the rotation of the Earth. I sent it to somebody.
Lead is electromagnetic too, guys. It still has a force. Sorry, I'm reading your damn comments.
I sent that to somebody. It's got 14 different publications in it. Each one of them is 10 to 20 pages long. 3 minutes later, guy comes back. They're all garbage. Like, what do you mean they're all garbage? You didn't read one of them. He goes, his answer was, they're all based on assumptions. Like, we'll point them out.
Right. Yeah. I mean, I'm not going to stand by something unless I actually understand it. I wouldn't. I would say, hey, look, to somebody, there's tons of evidence for gravity. I don't totally get it. I know people that are smarter than me that also say it could be other things. So until I fully get it, here we are. But knowing that there's that on your website and there's information that's out there, well, I'd be an idiot to make any further comment one way or the other without actually looking at it and trying to figure it out. So otherwise, you do have to appeal to an authority, right? You do have to just go with the folks that know better. So.
Well, the thing is, an appeal to authority is listen to them and don't do any analysis. That's it, right? That guy there, listen to him, take his words, the end. That's an appeal to authority. Pointing out, hey, look at these experiments and their detailed analysis of it. That's not an appeal to authority. That's an appeal to empirical measurements.
Getting frustrated with somebody who's not satisfied with an experiment that you feel is irrefutable, there is that territory.
It certainly could be refutable, but saying "nuh-uh" isn't a refutation. Not reading it.
Yeah, that's annoying. That's mature. I'm with you there. That stuff. But really, don't give God. I just hate that we give so much fuel to those fires. There's always going to be those idiots that are out there, acting a little silly. And they're on their own little trip for whatever reason. But, if they're going to be honest,
Mike, I got to tell you, I've debated a lot, and that's with very few exceptions. That's them. That's what they do. They don't look at these things.
Yeah.
They never do.
Well, that sucks.
It's not the exception. It's the rule.
Right.
There's a couple.
Yeah.
There's a couple.
Yeah.
Yeah,
I think that's a shitty part of this. I think that's a shitty part of this whole thing is if you're coming out of the gate with not a lot of respect for people that you're talking to, then it's going to be very difficult to find common ground, to have a good conversation, and to actually concede things or to learn or to even share things, right? So that's why it's very important for me to never give into this stuff. I want to show you that I do respect you, in a sense, and I do. I'm just not showing you that to placate you. It's the truth. It's the way I treat all people. And if I ask you a question, I want you to know that I'm being sincere and that I'm actually looking for an answer. If you think I'm an ass for asking it, that's a different level. But, at the end of the day, I hate that there is that aspect of this debate where people are coming out of the gate with total disrespect, total suspicion, and almost playing it like a game or like a joke to a degree, where it's about the sport of sort of gotcha. It's the sport of making fun of you. And right. Instead of just let's realizing that there's 300 other people watching, and that's actually what matters more than the ego interaction. So,
all right. So let's do this, Mike. Would you do an experiment to test if the Earth is a sphere or flat?
Sure. I'd love to.
Okay. There's an easy one that I've done 4 times. I measured the angle to the sun, and I had similar thing. I had 2 hypotheses, one that the Earth is a sphere and one that the Earth is a flat, and I tested both hypotheses at the same time. To measure the angle to the sun, though, takes more than one person doing it, because a single measurement, you may know this is the Eratosthenes measurement. He just had one measurement, and so he was unable. It wasn't an actual experiment, because if the Earth were flat, or if the Earth were a sphere, or if the Earth were an undulating saddle of some sort, that measurement could work on all of them. But if you do 2 measurements, then you can on the same day, then you can test whether or not the Earth is flat or a sphere or
So you're going to triangulate.
undulating saddle.
Okay. Does this have to do with your $10,000 challenge?
No.
Okay.
But I mean, it's kind of similar. It's in the same realm. The challenge is to use the measurements from a sextant to get the observer's position. And for flat earthers, the challenge is just using the presumption that the Earth is flat. You can't use the radius of the Earth. You can't use, the curvature of the Earth. You can't use, right? The first version, there's two versions. The first version says you couldn't even use the star charts because they're plotted on a celestial sphere. And then a couple complain. I'm like, okay, go ahead. Use the position of the stars on a sphere for flat Earth. Like, hold on. You really want to do that? Well, they didn't use that anyway. So, Mute Donkey says, I think you mean 3. No, you can use 2 to falsify one model or the other.
So would you be able to sort of demonstrate this maybe on a computer model or on a small model where you could show that the calculations wouldn't work on both?
Yeah, I can do it right now.
Okay.
I just draw it. Switch to a different pen because this one's a little bad. So. Okay, we're presuming flat Earth. There's the flat Earth. They don't read the chat. They're being mean to you. We already know that. All right, there's flat Earth. There's the sun. Right?
Okay.
If you have an observer somewhere, and they put a stick in the ground, like that, right? You can use the length of that shadow to get the angle, right? There's other ways to get the angle, but that's one way to get the angle. It doesn't require anything more than a stick, right? Everybody has a stick. If you don't have a stick, then sorry, you got bigger problems. Then you do the same thing at a different spot. Right? So remember, we're still presuming that the Earth is flat. So right there. So you do it in another spot at the same time. And what this does is this creates right triangles, and we can solve those triangles. Right? And we learned angle, side, angle, side. Right? Angle, 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 side, side, side. You remember all those things? Solving triangles. So if you know this angle here, and this angle here, and you also know the distance across the ground, which because people travel often, we know the distances across the ground. That gives us then the height of the sun.
Gotcha.
Hypothesizing flat Earth.
Right.
So if these two get drastically different results, then there's a problem for flat Earth. And if they get the same results, then that confirms flat Earth. It's supporting evidence for flat Earth. Right? So that's the hypothesis for flat Earth. At the same time, let me see if I can. Got a lot of non-blank pieces of paper. Oh my goodness. All right, I'll use this one. At the same time, we use the Earth. We presume, it's part of our hypothesis, that the sun is far away. And that's how you do a hypothesis. You just make up whatever you want. Richard Feynman says, you guess. And it's perfectly fine. So here's the Earth, and here's the rays of light coming towards Earth, nearly parallel. Not perfectly, but close enough that for this measurement, we won't be able to identify the difference. And you do the same thing with the sixths and shadows, right? Use the same measurement. And then you can do some again, trigonometry to determine the radius of the Earth. And if the radius of the Earth from all of the different locations matches, then that confirms and gives evidence for the Earth being a sphere.
Okay, so now you're saying that this is an experiment that I myself could do.
You and some other people at different latitudes. Now you're at a much low.
When we measure the angle, do we have to make sure that the stick that we're measuring the shadow of is the base of the stick is at the same elevation
as the shadow?
No, is the other stick. So my location,
the other person.
Location. My location, your location is the base of our stick at the same elevation.
The variation is extremely small, but we certainly could take that into account, and it probably will make a difference somewhere down around 4 or 5 digits in the precision. But our measurement of the length
those are
of
all the
shadow,
things that I mean, like just to be sure, like I would start to ask about, but maybe they're silly questions, but like I said, I'm coming from the standpoint.
It's a reasonable question to ask, and we can do the math for it to see how much of an impact it has on the results.
So there's something interesting about this idea of the location of the sun, though, and so I want to know if we can control for the perspective of where we observe the sun's location, if that's actually a true location of the sun, and how we can be certain of that, and just to be certain that we're not actually inadvertently creating a straw man argument for the flat Earth. And
this is calculating perspective.
So in a sense, right, this is what I mean. If you and I are on the same beach that is observing the sunset, right?
Yeah.
And there are, let's say there's multiple boats about 100 yards offshore, right? I'm a mile upshore, you're a mile down. Where I observe the sun setting is going to be directly over one boat. Where you observe the sun setting is going to be directly over another boat. The angles, the crepuscular rays that we observe are going to be centered on the boat that we're both seeing the sun go over, right? And so those sun rays, the angle of those, which actually, I think, in a sense, are coming from the source of sight, but not actually from the source of where the sun is, right? You see my point? So the idea of like where flat earthers will say, just use crepuscular rays to triangulate where the sun is. Well, that's not actually where the sun is. You understand what I'm getting at here?
Yeah.
And so
you can't use crepuscular rays to do it, because you don't know.
Rays show us, but they show us that we can't be certain that that's where so if I'm gonna measure the angle to the sun and have that shadow, I think we have to use a presupposition. Let me finish this point. We have to use the presupposition that the sun rays that are creating the shadow are the true sun rays, are the actual parallel sun rays, and the sun rays creating the crepuscular rays are the illusion. And where you see the sun and where I see the sun in relativity to where we're standing is the illusion to it to a certain degree. It's not the actual place.
Yeah, and it's all dealt with in the hypothesis and the prediction.
But
and the math is
testing. I know I'm being a stickler, but is that hypothesis already being built upon the presupposition of the parallel sun rays?
100% it is, yes. Absolutely 100%.
Why I can't get on board with it all the way.
I stated
that's why I can't get on
in
board
the hypothesis,
with it all the way
Mike.
Because that itself belongs to the heliocentric model only.
Exactly. That's how you do an experiment, Mike.
You can't, but no,
Mike, that is the exact way that you do an experiment. You take a guess, or you just do better than that.
Okay.
You don't. You take a smart guess.
Wait a second. I'm with you there. You take a guess, and if more and more of your evidence piles up, okay, I'm with you there. I'm with you there. But the idea that it's 100%, like
it's not 100%. That was our first topic. Nothing is proof in the formal sense. Nothing is 100% in the formal sense.
I would have to really get into the weeds with this. I would really have to get into the weeds with this. When you say that the radius, you can't use the radius of the Earth, although there is a sort of idea of like the disk plane of the flat Earth, and the idea of you can't use a celestial sphere, even though there is like the argument of a sort of firmament dome shape.
A dome isn't a sphere.
but it would,
you could use
half of a dome is half of a sphere.
Absolutely. You could use the stars plotted on a celestial dome. But they don't nobody has the stars plotted on a celestial dome.
I have to give you a 10-minute warning now. I do. Okay. I'm sorry about that. So if you want to move on to more concrete things right now, if you want to find a way to segue to a conclusion. So I'm with you there. And I do concede. I think that all people that are interested in this debate need to also consider the fact that even though it still can't be 100% proven, that we do need to consider compounding evidence, supporting evidence, piling up of evidence, and to really put a lot of weight into things that we can duplicate and recreate. And so I do appreciate what you just talked about there.
Yeah. So you have, I just want to clarify this. You make up whatever guess you want. And of course, if it's a better guess, it's a better experiment, you can actually draw a better conclusion from it. So yes, parallel rays, distant sun, Earth sphere is in the hypothesis. You go through the experiment. At the end of the experiment, you have confirmation that your hypothesis could still be correct. That's it. That's why I said very clearly at the beginning, science does not prove. At the end of it, I'm not saying you proved your hypothesis. I'm saying the hypothesis is still a valid argument. Then the other way is you look at it, you go through the end and it doesn't work. So you say the hypothesis is very likely wrong or falsified. I don't like the word disproven. Right. Falsified is better because it doesn't have quite that strength to it. Sure. It still could be correct and something in the experiment was wrong.
I like that. I appreciate that.
Yeah. So
I appreciate it. Well, I appreciate all of that.
So then, all right. So then what you do is you look at all of the masses of experiments that different people have done over time, and you say, all right, here's the ones that confirmed this hypothesis, and here's the ones that confirmed this hypothesis. So the ones that confirmed the globe hypothesis and the ones that confirmed the flat Earth hypothesis, which one's bigger, Mike? I know your answer.
Yeah, no, I definitely lean towards the globe. There's much more supporting, corroborating evidence for the model of the heliocentric, reality that that it describes. It is definitely supported by experiment. It is definitely supported by what's the word I'm looking for? I don't know. Cross like things support each other. It's not just just channels. One thing. They all tend to support
repeatability and confirmation.
They confirm each other, right?
All right.
I'm with that. But for all the other things that I've tried to wax poetically on is the reason why I still sort of say that there's good reason to probably continue pushing folks for the absolute truth. All
right. Well, let me come back to this. This book here is kind of a history of the writings of people talking about the Earth being a sphere. So the citations are pretty strong, pretty good. Lots of citations. I think it's chapter 2 that my wife just read this and she's like highlighting stuff. And underlining things. I love it. She read this while we were on vacation. I read a celestial navigation book. So this talks about, like we were speaking of before, how far back people were talking about the shape of the Earth being a sphere. And so give citations. So then this one, now somebody said in a comment, Monkey Cat Pat Pat says, maybe you should point him to that book behind you. You might learn something, but probably not worth a try. So this is a book, Off the Edge by Kelly Weil. I had her on a couple weeks ago, interviewed her. She just put this book out. It's pretty good book. It's more about the psychology. So Sweet. If you're interested in the psychology of flat Earth, this is a great book.
Yeah, sure. I definitely
am. She interviewed a couple flat earthers that are no longer flat earthers, both Seek Truth, Speak Truth, and Jose J.G. Gonzalez, friends of mine that I speak to weekly or maybe less weekly, depends. So good guys that used to be flat earthers and got out and said, wow, I was wrong. I'm so much happier. So
well, right
seriously.
on.
So Ranty got out. Ranty flat, he grew hair again. So I mean, what are you gonna say?
Get out of flat earth and into
All right.
keeps.
I got a couple more things, and then people are asking you to play the guitar on the way out. So would you do that?
Oh man, I have to go get my other guitar. I could certainly do that.
Yeah,
what do we want to
run, get it. I'll read. Can you? I don't want to. If it's all right, he's going good.
No, I don't care, man. It's all good.
All right. Many Karen says the argument exists because of frauds and narcissists. Very true. Very true. Dubay, Nodell, Jaron, Dearth, Oakley, Mitchell. I mean, the whole top left list. Yeah, it's not begging the question, as they like to say. It's assuming elements for the hypothesis. Yeah, according to the Oakley and QE thing.
I like it. Just pick a talk. We don't want to hear about flat Earth.
Yes. All right. I'll give you one more. We've got Girthop says, Mike, flirts aren't sincere. They fooled you. So there it is.
All right. So hit me with some flat Earth stuff. I'm not a flat earther, guys. I'm just trying to understand all the arguments and sort of be a bridge here, because I don't like the way that folks fight it. You know, we got too many things. Talk about what does it all matter? Well, then why fight over this? You know.
Have you played in bands, played live?
So yeah, I've been in bands ever since I was in high school, but the best I ever did was with this band, the Tall Weeds, who you can look us up at thetallweeds.com. And we were chasing the dream in the Hudson Valley of like 2010 to like 2014, and did like, you know, a whole lot of original music, but started getting into the, you know, the little fest and stuff, the summer fest and all that stuff, and played a few places and recorded a couple songs, and then everything fell apart, you know, bunch of egos. So, but now we're all friends again, and a bunch of old men. We might do it again, so we'll see.
Grithog, I pronounced his name wrong. Grithog. There it is. I found it. Thetallweeds.com.
Yeah, so we got some like pretty like decently produced, like two decently produced songs out there, and a couple other ones that were just done in a garage, and a whole bunch of other stuff that you could probably track down on YouTube and other places. So,
all right, so that was in New York. What are you doing where you're at now?
So my wife is she's a psychiatrist for the Army, and we've been stationed out in Hawaii for like 7 years now.
Oh, okay.
And I've started to grow some roots out here, and I went to UH for a little while, and now I'm doing a lot of umpiring and other things like that, and helping raise our 3-year-old. So,
what did you study?
So actually American Studies, which I don't know if you saw my latest post on TikTok talking about the shackles at the feet of the Statue of Liberty. It's really interesting. So I'm really interested in the way that our country has used history, right, to shape its domestic policy, and how we've sort of created this dialectic, right, of sort of political forces that are dictating the direction of our country. And a lot of it is the foundation does have to do with race. And so all of that really interests me. A lot of my life experiences have to do with that. And so, you know, that was a really interesting topic. So there you go.
So iSmack says, wants me to explain Great Circle Routes to you.
What's that? Explain what?
Great Circle Routes.
Okay.
So if you take a sphere, take an exercise ball, put 2 dots on it, and then grab a string and pull that string tight between those 2 dots. If that line kept going, it'd go all the way around and meet on the opposite side of that sphere. And that line all the way around, if you cut the sphere right on that line, you'd have 2 equal halves. So that's a great circle route. is
okay. I understand. Okay.
Yeah. So that's what it is. And so that's the shortest distance between 2 points on the surface of a sphere. So planes and ships try to use them as much as they can because they want to conserve fuel. Of course, ships can't go through land very well. So but when they're in open ocean, they use great circle as much as they can.
Sure. And they have to contend with reefs and everything else.
Yeah. And airplanes use them. They don't have as many challenges. They can fly over land and water. But there's rules, things like they want to be within a certain distance of an airport if possible.
That's right.
Or
right.
like
reason why they supposedly don't fly directly over, right, the South Pole.
Well, there is no one route that would bring you directly over the South Pole.
Right.
So I think you would have to arbitrarily pick some very small airports to do it, which of course there'd be no commercial value for.
So given that, and then so I see where you're going with this, but I think the way to definitively be able to offer a counterpoint would be to have a really reliable flat Earth map that would show us, for example, if you took Antarctica. Well, if you took Antarctica, for example, I think that there would be ways that even like guys like you and I could probably figure out a way to do this. But if you took Antarctica, where all the sort of coastal bases are, right, all the outposts that belong to all the different countries, and they're all sort of marked and everything, and you laid that out as the circle, as the ring around the realm, and then we're able to sort of say, well, when the plane flew over Antarctica, it went over this station and it went over this station, and map that out on where it would be on the ring. And you would show that it's either completely ridiculous or possibly plausible. Do you see where I'm getting at with that?
It's been done.
Okay.
It's been done a lot of times.
But I understand the point.
And you know what the flat earthers say? They have a couple. They're like, never happened. That flight doesn't exist. Jet streams, which doesn't answer it. Or my favorite, we don't have a map. We don't need to have a map. Of course you need to have a map. Flights exist. Airplanes exist. People get around. Somebody's using a map.
Right.
So,
well, you think there's a possibility that there could be a third sort of explanation that the argument between this flat Earth and this globe Earth is sort of leading all of us down a different the wrong path, maybe? Or do you think that is absolutely, without a doubt, the only plausible hypothesis?
Well, the Earth certainly is just one shape.
Okay. Well, we'll agree to that. Sure. So whatever it is, just like whatever our God is, whatever it is, it's all of ours, right? So whatever shape the Earth is, it's all of our shape. There's only one. I'll agree to that. Yeah. So what was your point with that? I didn't mean to cut you off.
Well, there is only one shape. So is there some other thing? Well, I don't tend to think so, that there is some group that's trying to introduce some alternative idea to cause dissent in the flat Earth, globe Earth realm, because it's actually kind of small. If there were some, say some foreign power, from America wanted to mess with America by trying to influence people to think something that was wrong, I don't think flat Earth would be the one. I think it would be something else, maybe something that's just one letter of the alphabet that often follows is in front of the letter U. That one was big enough to mess with stuff, but even that, I'm pretty skeptical about that being an actual explanation for it.
So are you cheering for the aliens to come? Are you looking for them to come unite humanity?
No, I'm certain that I definitely aliens showing up would not unite anybody. But I don't think there's.
It is
any
funny that the
coming.
Politicians use that as a point, though. I do find that intriguing as well.
What point?
well, I think that's why I brought it up. I mean, that's something that a lot of the sort of New World Order conspiracy theorists will point to.
But I haven't heard
they use the idea of space. So politicians, like everybody from Reagan to Bush to Clinton, everybody talks about the New World Order. But I think
they didn't talk about aliens.
Yeah, I think Reagan is the one who famously waxed poetically that, if we only had some external enemy that could unite the world, like an invasion of something, and then we wouldn't have this fight.
If aliens have enough technology to get here, we could not stand a chance against them.
Well, true that, but I think that they make the antidote. They use this line, and then folks are like, hey, they're going to fake it to create the New World Order. It's
Molosus, Q before R, not you. No, I mean when you're spelling words, not in the alphabet. But I get that. All right. Well, anyway, you gave me 10 minutes, and it's been about 10 minutes. Yeah, Mike, thank you. Here's the deal, I would love to do that experiment, and sure. I would need you to understand.
We could probably think of better experiments to do, especially since I'm on an island here in Hawaii. We could probably figure out other things to do, but I'm definitely down to do that.
Okay, but I'll see on TikTok. People, he's on TikTok. Find him in the description of this. If you're on TikTok, go tell him to use his powers for good. And drop that last 10% of the flirtiness there, because he can do better. All right,
guys. Well, thanks a lot. I appreciate it. You guys have a wonderful night. We'll talk to you later. Let's get out of here.
All right, everybody. Thanks a lot. We'll see you coming up next week. We've got 33 UC just confirmed earlier. Oh, geez. What was I thinking? But yeah, 33 UC is always a good show. He's super derpy. I like Mike, and he was in defense mode. But you go to TikTok and you will see that he is not taking crap from flat earthers there. So that's it. All right, everybody. Thank you for coming. Thank you for sticking around. You don't have to go home, but you can't stay here.